Hi everyone, welcome to this continuation webinar of the Salesforce APIs, and we're going to be talking about integrating today with a Bulk API. We're going to be talking about fast parallel data loading with the Bulk API. So if you've been to any Salesforce presentation in the past, you're probably familiar with our safe harbor statement. Basically, you don't want to make any purchasing decisions on forward-looking statements that we might make in today's presentation. If you want to read the entire safe harbor, go to salesforce.com. My name is Steve Bobrowski. I'm here with Sean Regan. We're both architect evangelists with a group out of engineering called Technical Enablement. And there's our Twitter handles up on the screen if you want to connect with us and ask us questions. Speaking of social networking, Force.com is all over on all the major social networks. Here are the handles if you want to connect with us. On Twitter, we have Lauren that's taking a look at what's going on today. If you want to connect with us through there during the webinar today, feel free to do so. So what are we going to talk about in today's webinar? Basically, it's this. How fast can you load data into Salesforce? Let's put it another way. How many records can you load into Salesforce in 1 hour? So with that in mind, let's take a closer look at the idea of data load throughput. So if you look at this chart here today, basically what we're going to try to do here is we're going to try to increase your knowledge about data loading so that you progress your ability to load data into Salesforce. You know, data throughput rates maybe from over on the left, and move your knowledge set over so you can load things faster over to the right side of this graph. And how are we going to do that? Well, we're going to do that with parallel processing. So what's parallel processing? Probably most of you on the webinar today already understand that concept, but for those of you that don't, let me just use a real simple analogy, digging a ditch. So let's say you want to dig that ditch in your backyard and you're the only person that's doing it. So that's called serial processing. And if the ground in your backyard is pretty hard, it's going to take you a long time to dig that ditch. Parallel processing is when you go down to your local hardware store, buy a whole bunch of shovels, invite all your friends over, your unlucky friends, and you dig that same ditch. You break it up into smaller units of work, and you all work at the same time to dig the ditch, and then you can relax. So if you think about it, there's the concept of the degree of parallelism in that analogy. Basically, it's the number of processes or threads that you're associating with the job or the operation that you're working on. And so the higher the degree of parallelism, in theory, the faster you can complete that job. So optimal parallel processing looks a little bit like what we see on the top part of this graph. Down below, just for a baseline, we see serial processing. So think loading records into Salesforce now. So in the case of this job, we're trying to load 20 million records into Salesforce. You can see the serial load takes quite a long time, but if you break that up into 4 smaller jobs of 5 million records apiece, and then run them all at the same time, in theory, the idea is that you'll complete the job in 1/4 the time. Now, that's optimal, okay? Suboptimal parallel processing looks like this. So even though you've broken up your big job into 4 smaller jobs, you don't necessarily decrease the amount of time that it's necessary in order to complete the job. So why might you see something like this? Well, the reason is because there's things called throughput inhibitors like locks and exceptions that will slow down the ability for those parallel jobs to do their work. So this, if you wanted to connect this to the analogy of digging a ditch, it's kind of like putting all your friends too close together in their backyard and they start banging each other in the head with the shovels, and you really don't make any progress. So what we're going to do today in the webinar is we're going to walk you through a number of case studies. And these are case studies that are built from some work that Sean did with some customers. Sean, you tell everybody a little bit about how these case studies came about.
Yeah, so we work in a group called Customer-Centric Engineering and Salesforce, and within our investigations, we see, as Steve mentioned, some of the issues that our customers are having out in the field. And one of the things that we've run into time and time again is, when customers are trying to load large data volume and they're having issues getting that data into the system as fast as they want to. And so we see real-life examples where customers have challenges with their degree of parallelism and the throughput that they're getting out of the jobs. And so those investigations are serving as the basis for this webinar and the information that we're going to be presenting here today.
All right, so what we're going to do as we go through these case studies is we're going to get hands-on with the Salesforce Bulk API. We're going to contrast serial and parallel data loads so that we can see what's our degrees of parallelism and compare throughput. And then we'll identify and avoid those throughput inhibitors that I talked about a little bit earlier so that you can understand how to get the maximum throughput on your data loads. Now, before we get started in those case studies, I want to do a little bit of prep here to get everybody up to the same speed. So the first thing I want to talk about is I mentioned that we are going to be using the Salesforce Bulk API. So hopefully everybody on the webinar today here is familiar with the Bulk API. It's our API that is used to asynchronously load large sets of data into Salesforce very quickly. It's a REST-based API, and it actually powers some tools that Salesforce produces, as well as a number of third-party tools that you might find out on the App Exchange. Now, I said it's a REST API, and it actually makes it very easy to use any programming language you want to build your own custom tools for loading. And a lot of our customers have to do that because they have very specific needs about the way that they want to load data. So what we're going to do today is we're going to actually be showing a bunch of code snippets that are Java, and you'll get a sense for how to use the Bulk API using Java. The second thing I wanted to cover quickly is the schema that we're using to support today's demos. So it's a very simple schema. It's 3 objects that we really need to pay attention to here. The most important one is the orders object, and we're going to be loading orders. That's the object that we're targeting for the data loads. The orders object is also related to 2 other objects in account and catalog. And notice the relationship there is a lookup relationship. Now, I point that out now because we're going to focus on those relationships in just a bit when we get into some of the case studies. So just remember that visual when we get going. And one of the things that we wanted to do is we wanted you to leave the webinar today with just a key thought. If there's one key thought that we want you to leave the webinar with, it's RIP. Okay, RIP is an acronym that we invented. So the idea is that if you want to have bulk API loads that rip, you need to realize, you need to investigate, and plan. And we'll explain more about what we mean there and when we go through the case studies, and you'll see why we invented that. So let's get started with our case studies. The first case study that we want to go through is a serial data load. And it's a baseline case study that we'll use to kind of get started in understanding what the degree of parallelism is and throughput rates. So this is a visual that kind of depicts what we might expect for a serial load. It's one job, and we're going to be doing this load for all of our case studies, by the way. So it's one job. We're going to be trying to load 1 million total records. The job will have 100 batches, and each batch will have 10,000 records per batch. Okay, so before we leave here, now notice we're just using one available thread that's out there. There are lots of potential threads actually available to your data loading jobs, but we're not going to use all of them. We're just going to explicitly use one because what we're trying to do here is a serial data load.
And for those of you who may not be familiar with programming languages, you can really think of those threads essentially as the shovels, right? That are actually doing the work in a parallel load.
Right. Okay. So how do you configure a load in using Java using the Bulk API? So we're going to start showing you some code snippets here. So this first one is just some Java code that creates the job, and there's a lot of code here, but the main thing we want to point out is just we're setting up the concurrency mode as serial. Second part that we do is we need to create our batches. Now remember on the previous slide I pointed out that we're going to be doing 100 batches of 10,000 records per batch. And the reason that we have to do this for our job is because there are limits associated with the Bulk API that I think probably some of you are already familiar with. The 2 most notable limits are the 10 million bytes per batch and the 10,000 rows per batch. Now, the load file that we're using for this demo, we're not going to have to worry about that byte limit. We're just going to be focused on the 10,000 records per batch limit. So once we get our batches all set up, the next code snippet here just takes those batches, sends them off to Salesforce, waits completion, and then we can check the results. So it's pretty straightforward. The code that we're doing here, by the way, will be available on GitHub, and we'll give you a bit.ly at the end of the webinar that you can use if you want to download these. So Sean, why don't you go ahead and walk us through some of the results that we've seen for a serial load.
Sure, Steve. Thanks for that great introduction. So let's go ahead and go into our Salesforce environment. And so what we see here, we're actually on the monitor bulk data load job screen, and we're going to spend a lot of time in this screen, throughout the presentation today. And so for those of you who aren't familiar, I know probably most of you are, but for those of you who aren't familiar, you can navigate to this screen down within setup under the jobs and the bulk data load jobs area. And this screen shows us a bunch of great information. We can see what's in progress, as well as the jobs that have completed in the last 7 days. And in the case of this serial run, we've gone ahead and run this job in advance of the webinar, and you can see why it actually took a little bit more than an hour for this to complete, so we didn't have time to do this live. And also on this screen, you can see that there were the 1 million records that were processed, like Steve mentioned, and then out of that 1 million records, we had 0 failures. And so let's go ahead and drill into this a little bit more to see what additional information we can find out about this particular job and how it ran. So we saw that there was 100 batches, which is what we expected, and none of those batches failed. It completed, and we talked about the records processed and the records failed. I also want to point out the number of retries within this job. So we saw 0 retries when this executed, which is what we would expect out of a serial run, since nothing was actually running in parallel within this environment and we were doing a data load. And if we look at the individual batch results, we can see, a few of the batches here in the screen, and it looks like the processing times were, in the 35 to 42 second range. In each of those batches, as we would suspect, processed their 10,000 records without any failures and without any retries. So this was really a pretty straightforward serial run. There was nothing really apparent here that went wrong with this run. It looks like it did pretty much what we would expect it to do. So let's go ahead and go back to the presentation, and we can summarize what we saw in this run.
All right, so everything here pretty much aligned with what we expect, right? We loaded the 1 million records into our database, and it took about, we did a number of these runs. It took an average of somewhere around 52 minutes on some of the test runs that we did before the webinar. There's another stat that we show here on this screen called work completed, and that comes from some of the internal tools that we have access to here at Salesforce. That gives us a measure of how much work our servers do to actually complete the job. So in this case, we kind of had an average of around 48 minutes. The reason I mention that work completed is because if you take the work completed divided by the runtime, we can calculate the degree of parallelism that the job, that the load actually used. So what we're trying to get here is some baseline measurements for parallel runs that we'll be doing in a minute. So the baseline throughput here, when we have a degree of parallelism that's approximately 1, is around 20,000 records per minute.
And Steve, one more quick thing I really want to emphasize too, that work completed number. Pay some special attention to that, because that really does gauge how much work our server is actually doing in order to load a given number of records into the system. So we'll want to be comparing that throughout the runs today. Yeah,
good point, Sean. We're going to come back to that as we do each case study. So how are we going to increase throughput? Okay, so let's go to the next slide, Sean, and we'll show everyone that this is a graph that we're going to be coming back to again and again throughout the webinar to get a sense of how well we're doing with our loads. So all we've plotted here on this graph is, unfortunately, it looks like the axes have gone. I'm sorry about that, but we see them here on our previews. Anyway, up on the left is throughput records per minute, and that is basically what we talked about just a while ago. And on the lower axis is degrees of parallelism. So with a degree of parallelism 1 and a throughput of 20,000 records per minute, we can start to plot how well we're going to do as we go further to the right as we add additional degrees of parallelism. And we've extrapolated a line for the optimal loading that we want to see up and to the right, as you can see. We're going to come back and hopefully the axes will appear on a later graph here. But all right, so let's switch gears now and go to another set of case studies around parallel data loading. So again, visually, let's take a look at what a parallel load you might expect it to look like. So in this case, what we've done is we've taken that big job and we're going to feed it to multiple concurrent threads that are running out there. Same number of batches, same number of records, all that stays the same. It's just that we are taking advantage of the number of threads that are available at any given time out there on the platform. Now I say that the number of threads that are available, and that's not a constant. So why is that? Well, you might be running multiple jobs in your org that are using some of the threads that are available, or there might be other tenants out there that are using available threads for their jobs. So at any given time, you're going to see, as you watch a parallel load, you're going to see those number of threads being used kind of oscillate a little bit. And you'll actually see that live here in a minute when we run through a load. Now, to configure a parallel load is really easy. We're not going to change hardly anything in our Java code except for this one setting here. The concurrency mode is going to be switched from serial to parallel. Okay, so Sean, I'm going to turn things over to you in a minute here, but I want to tell everybody to watch for a few things here because Sean's going to run through and show how locks can significantly affect the effectiveness of parallel loads. You're going to see a whole bunch of wasted processing capacity, which results in the throughput that we're not looking for, and it's coming from a bunch of failures. Also note that Sean's going to point out how the retry logic that the platform automatically implements to try to work around some of these problems, it's really not all it's cracked up to be, and it doesn't really solve the problems that we're facing here. So Sean, why don't you take us through the first parallel run?
Sure, Steve. So let's go ahead and move back into our Salesforce environment. And so we're back here at the monitor bulk data load job screen. And in this particular instance, we've gone ahead and we've run this job in advance of the webinar too. It took about 9 minutes for it to complete, which doesn't seem too bad on the surface, right? The last one took a little more than an hour. We ran it in parallel. This ran for 9 minutes, but there's some other really important information here. One of the things that I wanted to point out was that out of the million records, there was only about 323,000 of those records that were actually processed in the job. And so that right there tells you that something went wrong, and a lot of records, it decided it couldn't even process a lot of the records in the run. And out of those 323,000 records that were processed, 199,000 of them failed. So there really, in this 9-minute run that executed, we only loaded about 123,000 records into Salesforce. So the picture's starting to look a little worse now. So let's go ahead and dig a level deeper and see what additional information we can find out. So as we go into the job screen, we can see some more information here. We can see that there was only 4 out of the 100 batches that completed and 96 failed. We see that this job actually completed. We talked about the records processed. But what I really want to point out here is this number of retries, 996 retries. Now remember that there was only 100 batches in this job. So that is nearly 10 retries for every single batch in this job in order for this to run. And so if we look at some of the individual batches, we can see that most of the jobs had just a subset of the 10,000 records that were processed, and a very high percentage of those actually failed. And then we see the 10 retries per batch. that was executing here.
Well, that really didn't work out, Sean. So what's a customer to do in this case? How can they dig down and find out what happened here?
Yeah, so that's a really great question, Steve. So the next thing that we need to do is we really need to try to figure out what the problem was. And we have on the surface, we have the state message. If you highlight over this, we can start to get a little bit of information about what happened. We're seeing that there's too many lock failures that actually executed. And so in this environment, what's actually going on is there's these batches that were being attempted to run in parallel, and these batches were trying to take out locks on some particular record within the system, and that was causing failures because many of these batches weren't able to obtain the locks. And so the Salesforce platform, it tries to implement retry logic in order to get that data in successfully. But when you have these types of lock exceptions, you can see rather extreme situations here where it doesn't go in, or different degrees of lock failure. But ultimately, in the end, it really can impact the throughput that you get within the job that you're executing. So let's go ahead and go back into our presentation and summarize the results here.
Yeah, so I think the overall summary here is basically that we had a failed load. we really didn't accomplish what we set out to do, which was to load those 1 million records. The runtime was only 10 minutes, but is that a success? No, that's not really better. The key thing here I want to point out though is look at how much more work was completed for this load, and again, it was really a failed load. That work, that extra amount of work that was necessary, is largely due to the fact that there's a lot of locking as well as the retry logic that was automatically implemented in order to try to work around the locks. So for the records that did load and the degree of parallelism that we had, it basically works out to around 20,000 records per minute on average, and a degree of parallelism somewhere around 16. So the key problem that we got to deal with here is these lock exceptions. But before we do that, let's just plot this next load on our graph and see where it lines up.
Hey, Steve, look, our numbers came back.
yeah, it looks like, at least here, it looks like the axes are showing up now. So if we put this parallel load here, we're close to 16 on the degree of parallelism, but we're nowhere near that optimal line because the throughput is still around 20,000 records per minute that we saw for the serial load. So this is highly suboptimal, and this is really not what we want to deal with. And unfortunately, a lot of customers do this kind of configuration for parallel load and then just don't know what to do at this point. So Sean, why don't we go to the next slide?
Sure, yeah, Steve. And before we do, one thing here, I mean, this diagram really kind of depicts shooting yourself in the foot, because you've used up a lot of degrees of parallelism, and you have the capability to be on that optimal line for the throughput, but you've essentially not gotten any additional throughput, and you've used up a lot of your processing, your asynchronous processing capacity.
Cool. Okay. So what are we going to do now, Sean? I mean, how are we going to work around this problem? We have all these locks. What do we do?
Yeah. So, so let's go back to our analogy, right? So when you're running the Bulk API, the one thing that we want you to remember and to take away from this is you got to make it rip, right? So the first part of that is to realize, right? So we know, because we've talked about that locks, can certainly be a major inhibitor to your parallelism and your throughput. And so the second step of that is, and what we have to do next is we need to investigate, what was actually causing those locks. So we saw that it was the locks, but we still don't know exactly where those locks are coming from. So once we figure that out, then we can plan for what we're going to do to actually manage those locks. So with that in mind, let's go ahead and move into our our second parallel load. And this load, we're going to focus on eliminating the locks once we find them by modifying the schema within the system. So let's go ahead and move into our Salesforce environment. So here we are. We're back at the monitor bulk data load jobs, and you can see we don't have anything running in the environment right now. Let's go ahead and take a look at the object that we're loading. Here's the order object. And within this, we see the two relationships that were in the entity relationship diagram that you saw earlier, the catalog and the account. And if we go into the catalog object and see how that's configured, this is actually set up as the default configuration. It's not required. If the lookup record is deleted, it's set up to clear the value of this field. And when it's configured this way, the platform is going to validate that this lookup record exists, but it's not actually going to lock it. So we know that we don't have a problem there.
Okay, so we know the locks aren't coming from there, right?
Exactly, exactly. So then we can move on, take a look at the other one. If we go to this account field, we can see, again, it's not required, but we've got something different here. It's actually configured to not allow the deletion of the lookup record when the lookup record is deleted. When lookups are configured this way, not only are they going to validate that lookup, but they're going to actually take a lock against that lookup record at the time that they do it. And so this is what's actually causing those lock failures that we saw. So if we go ahead and configure this back to the default configuration, and now we've just eliminated this lock, and we can go ahead and try to execute this load again.
Okay, so just that one small configuration change is going to get rid of those locks that were causing all of our problems. That's what we're doing here, right?
Right, exactly. So we're going to make one slight configuration change, and then we're going to load in exactly the same data file that we loaded that caused all of the locks to occur.
All right, live data loading. Here we go.
So, so what we're going to run is we're going to run this bulk load parallel job. And this is just the Java application that you saw. And we're going to load the order data CSV file, which is our master order data that has the million records. And we'll go ahead and kick this off. And if everything goes well, this is going to start running. And we can go ahead and move back into our Salesforce environment and take a look at what is going on with this job. So we go back to the bulk data load job screen. Oh, great. So we can see that we have this job that's running, and it's already started processing records.
Oh, wow. Look at that. It's already processed, what, 15,000 records?
Yeah. And actually, if we go ahead and we reload this screen,
wow.
So it's already at 58,200 records with no failures. And one of the things that I want to make sure that you're aware of, since you don't have the access to the data file, is we actually have 500 accounts in the system loading 1 million records, so that's approximately 200,000 orders per account. And that's all the skew that it took between our loading records and the account records to have such a high failure rate when we ran in parallel. So let's go ahead and drill into this job, and so we can take a look at some of the detail of what's going on. And so we see that it's queuing up batches as we're running. We've got 26 queued up. There's 20 that are actually in progress. We've completed 10 so far. We've already loaded 20% of the data file at this point.
So that 20 there, Sean, that's the current number of threads that are actually in use for this job, right? And we talked how that can vary.
Yeah. So that's a really great point, Steve. So this in-process batches is how many batches that are running at the point in time that you refresh the screen. So if I refresh this multiple times, we're going to see that number floating around. So you see 16 there, 16 again. If I keep doing this, now it's 15. And so, it's pretty typical to see, the number of batches being processed at any given time ranging anywhere from, 14 to, I've seen as high as 22 batches processing all at the same time. And that high degree of variability is going to impact shorter runs that are executing, much more than longer runs. It kind of averages out over time. But and so that's where we'll see in some instances, we'll see, maybe a little bit faster speed than we would expect in these short loads, or slower speed.
So, so one other thing I wanted to ask you and try to make sure everybody understands is that we're not throttling this load in any way. We're going after as many threads as we can get at any given point in time, right?
Yeah, exactly. So we're trying to use up as much of our asynchronous processing capacity to get this load in as quickly as possible.
Okay. Now, I can anticipate some of the questions that might be popping up out there right now in the chat window from some of our viewers, and one question that comes to mind is, we made a configuration change here to the org. Is that is that what we're recommending in all cases here to get around these locks? Explain a little bit more about that to everyone.
Yeah, sure, Steve. So another really great point. So in this particular case, we went ahead, we made that configuration change. Sometimes that works for customers, to make those changes on a permanent basis because they really don't need those fields to be required at that level, or they don't need it configured in that way. In other cases, those types of configurations can be changed if you're doing like a large initial data load, and then after the load has been completed, you can change those values back to the way that they were. And then lastly, if you might have situations where you might have an integration that's executing in a live production environment, and you don't have the option to make that change at all. Okay. And so we'll explore that in a few minutes.
Yeah. So in summary, we're just showing you one way to work around these locks, and we're going to show you some other ways if you can't make that kind of configuration change. Okay. Look, hey, the load's already finished. Wow.
Yeah, so let's take a quick look at the numbers. We've got 100 completed batches, 0 failed progress. It completed the load. We got all million records into the Salesforce environment, and we had 0 failures, and we had 0 retries, which we would expect to see because we did eliminate the lock. And then at the batch level, we're seeing 35 to 42 seconds, so similar processing time for the batches. And then we can see here that this entire load, we got this whole entire load of 1 million records into the system in under 4 minutes with this parallel load. So nice. Much faster.
Nice.
So let's go back to the presentation and look at the summary of the results here.
All right, great. Excellent job, Sean. We got all 1 million records in. The runtime, we averaged out and before the webinar at somewhere around 3 minutes, 30 seconds. The amount of work that was completed on our servers, only an hour's worth of work. So we really cut down those, getting rid of those locks really saved us a lot of work. So what that results in is a throughput rate of around 320,000 records per minute and a degree of parallelism around 19. No key problems here. So let's go to our graph and see how that plots out. So again, the degree of parallelism 19, that's why we moved so far over to the right. And then the throughput rate is up around 320. So you can see that falls right on the optimal line, right, Sean?
Yep. Yeah, and this is a very, very well optimized load.
Okay, great. All right. So we talked a little bit about how some folks might not be able to do that kind of a configuration change, right, to eliminate the locks.
Yep.
So what about let's start talking about other ways to deal with it then, Sean.
Yep. Yeah. So there's a couple of options. We saw the elimination, and as an alternative, if we want to leave those locks in place, we can actually order that load file by those records to try to minimize the number of occurrences where a lookup record or a record that's being locked occurs across multiple batches that are being executed in parallel. So let's go ahead and take a look at our next demo, the parallel load 3, where we're going to make some changes to actually avoid the locks with the order data. So we're back here in our Salesforce environment. We can come back. We can see there's no jobs that are currently executed. The first thing we need to do is put our locks back in place.
Right. So we're gonna go back to what we did with the initial serial load and the initial parallel load, get that configuration back to the way that it was, right?
Yeah, exactly. So we'll come back to the account. We're going to put this back to not allowing the deletion of the lookup record. We'll go ahead and save this. And so now we're locking on that parent account record once again. If I were to actually run the load that I just ran, if I just reran the same thing, I would end up having the scenario where it runs 10 minutes with all the lock failures. but we're not going to do that. We're going to come out. This is a Excel file. I've made a copy of the order data file. So this is exactly what the order data file looked like. And I renamed it order data ordered. And so in this file, you can see that the account records have no particular order here. And this is the one that we're locking on.
Right, that's the field where the locks are being taken out on.
Yeah, so I'm going to go ahead and sort this file by that field. And this takes just a few seconds. There's a million records, so Excel is done. And one thing that I want to point out is I'm going to go to line number 50,000. And so as you recall, our batches actually are 10,000 records each. So this is the transition from the fifth to sixth batch. And what I want to point out is that, we know that when I mentioned before, there's 2,000 accounts per, or 2,000 orders per account. And you can see that this account ID spans across two batches, right? It's not being cut exactly between the batches.
And that's important because two batches are going to try to take a lockout on the same account, right?
Yep, yeah. And so we want to see exactly, what's going to happen when it tries to do that.
Okay, so you saved your file and we're ready to fire off a new load, right?
So I close that down so that my Java program can get a hold of it. And you can see I'm running the exact same program, the bulk load parallel program, but this time instead of putting in order data CSV, I'm going to put in order data ordered CSV. We'll go ahead and execute this. And if all goes well, this is going to start running, and looks like it's going good. So we can come on back into our Salesforce environment. And let's go back to our favorite bulk data load job screen. Okay, perfect, great. This is what I like to see. The job's in there, it's in progress, it's already started executing. We've got 26,000 records processed with 0 failures.
Wow, that's looking a lot like the last load, Sean.
Yeah, actually, bearing some great resemblance here. 10% loaded already. Let's go ahead and drill into this to see if we can get some more detail with what's going on. We'll reload. And so we're almost at 20% loaded already. And we've got, similar in progress batches. We kind of expect to see that. 7 that have completed. We have 0 failures so far. We have 0 record failed. And as of right now, there's no retries either. So this load's running really good.
All right, so I can already see in the chat window here as this load runs, Sean, I can already see that someone's asking to understand a little bit more about how to manage locks, right? So maybe this is a good time to go to the presentation and take a look at some stuff.
Sure, that's a great idea. Let's go ahead and move on back.
Yeah, so you just kind of knew from your previous work that a lookup relationship configured in a particular way is going to take out locks. What other kind of scenarios, some configurations I should say, are going to be taking out locks, Sean?
Yeah, so this is a really great question, because a lot of people ask, so how do you know what to look for, when you see these locks that are occurring, and there's a number of different ways that locks manifest themselves, which you can see here, the master detail relationships, lookups like we saw in our examples, roll-up summary fields and triggers and workflow rules. There's quite a few different ways, and there's ways that you can manage each of these, and even in combination. So if you stay tuned to the end of the webinar, we're going to actually provide you guys with a link to the great wiki article that I wrote, which really takes all of the experience that I learned from the investigations and provides that. So that you can learn how to manage these locks as well.
All right, so don't drop off the webinar. We'll give you that link in just a few seconds.
Okay, so let's go ahead and move back and see how our load is getting along now. So let's go ahead and refresh this.
Oh, there we go. We're nearly complete. Wow.
Yeah, so this is moving along really great. You can see we've got 75% of our load, or 750,000 of the million records that have been loaded in. But also, I want to point out that we have no failures and no retries. Now, this is really important to note, because when we looked at that CSV file that we're actually loading in, we still had account IDs that were being locked that spanned multiple batches. So in other words, we didn't have the perfect load, right, where every single batch, had different IDs that it was trying to take locks on. But even in spite of that, we have absolutely no retries and no failures that are occurring in this load.
Right.
And the performance that we're getting is really very comparable to what we got in the last parallel.
Wow, this time it actually worked out better. Look at that.
Yeah. So, and this is actually that degree of variance in shorter runs, where you can see faster times in certain runs than other ones, and it's all just based on the degree of parallelism that you got for that short 3-minute and 44-second run. And so if we take a look, we see the batches, all the records processed, no failures. The run times were, kind of in that same 30 to 45 second, range per batch.
Looks pretty much the same there. Yep.
Okay, so let's go ahead and move back into our presentation to summarize the results here.
Okay, so if we summarize this, we got all the million records in. It took, again, around 4 minutes. There was about an hour's worth of server work completed. By our calculations on average, it was around 250,000 records per minute, and we got an average degree of parallelism somewhere in the 16, 17 range. So there was some minimal overhead due to the locking, and that's why we see, on average, a little bit less optimal, but it's pretty darn good, right? So let's go look at the visual, and you can see if we plot it up there, it's right close to that optimal line. So like Sean said, even though there are multiple concurrent batches locking on the same account in this case, that overhead is pretty minimal, and we're doing pretty darn good here, and no configuration changes.
Yeah, and this graph points out, you see that the parallel 2 and the parallel 3 jobs, they actually ended up getting different degrees of parallelism, again, because of that variation. But what's really important is that for whatever the degree of parallelism that you get, that you're very close to that optimal line, in terms of throughput when you're trying to optimize,
right.
For your throughput. So.
Okay. Hey. Before we go to the next case study, Sean, I forgot to mention while we were waiting for the last load, I want to plug a new blog post that came out this morning. It talks a little bit about some of the side effects, a particular side effect that you can get when you load lots of data in, and that has to do with search indexing. So please go out to blogs.developerforce.com. Once you get really proficient at fast data loading, you're going to want to look at that and understand a little bit more about that.
All right, so and that's great, Steve. And one other quick thing too that I wanted to point out that I forgot is that when using the Bulk API, it's really important to realize that the variation in the degree of parallelism that you get, it's based on what you're using in your asynchronous processes. It's software as a service, so it's a multi-tenant platform. So ultimately, the bottom line is your mileage will vary to a degree, but what's really important and what we're trying to get across here is don't shoot yourself in the foot, right?
Right.
Get the mileage that the platform is actually going to give you, and you will get exponentially faster performance than, if you're doing things that are going to inhibit your parallelism.
Cool. Okay, so we're gonna now just real quickly. We don't have any time to do more demos or anything like that. We gotta wrap things up pretty quickly here. But we do want to just quickly mention controlled feed parallel data loads. Now this is kind of a load where we talked about we weren't throttling anything before. Now we're going to talk a little bit about a scenario where we might want to do some throttling, right, Sean?
Yeah, exactly. So put simply, the controlled feed data load is just loading your jobs one after another as they complete, right? So you kind of order them into the system. And really that some of the benefits that you can get from a controlled feed data load when they're used properly is the ability to throttle and use a specific degree of parallelism that you want to load for that particular job. You can also use it to manage inhibitors in more complex jobs, like, for instance, if you have data SKUs or if you're trying to manage multiple locks. And if you want to read, there's a whole bunch of information about that that's out in the wiki article that's just a couple of slides away right now that you can take a look at. And so if we plot those control feed loads on the graph, the one quick thing that I wanted to point out here, because this graph is not in the wiki article, is that those loads actually fall on the optimal line, because all you're doing is you are throttling your degree of parallelism within those loads, but you're not inhibiting the actual throughput of those loads. So it allows you to kind of move up and down that line, that optimal line where you want to be.
Right. Okay, so Sean, this is Sean talked about this article that he wrote. It's up on Developer Force. In general, you should be visiting developer.force.com/architect on a weekly basis. This is where our team publishes all sorts of great tips and articles on techniques on how to take full advantage of the platform. But there's a bit.ly right here, Bulk API repo, that you can take a look at that wiki article, and it's very extensive, so I encourage you to take a look at it. All right, so a quick recap of today's webinar. You want to make your parallel data loads RIP. So RIP is that acronym that we talked about for realize, investigate, and plan. First, you want to realize what's inhibiting perhaps the parallelism and throughput on your loads. Then go ahead and investigate what's causing those inhibitors. In most cases, like we showed here today, it's locks. And then you want to work up a plan for dealing with, working around those inhibitors, in this case, the locks. And again, my name is Steve Bobrowski, here with Sean Regan, and there's our Twitter handles again, in case you want to connect with us and reach out to us on Twitter. But right now, we know that there's quite a few questions that have been asked throughout the webinar. I actually tried to address some of those already. But let's go ahead and see if we can spot some here, Sean, that may be of general interest to all the folks out there. So what about batch limits, Sean? We were doing 10,000 batches. We were doing a certain number of batches within, the question is how many batches per hour can you run with the Bulk API, right? So there's some standard limits. What does somebody do if they need more batches per hour?
Yeah, so so certainly, if you're doing extremely large data loads, a lot of times where we see that is when customers are doing extremely large data loads, they need them increased for just a short period of time. You can certainly contact Salesforce support if you need to get those limits raised.
Okay, great. So another question was, how do you know kind of what the lock, what's causing the locks? We identified in the lookup relationships, but I think it's probably worth repeating here that the article that Sean wrote, it really has a full explanation of a lot of different scenarios that cause locks that might be inhibitors for fast parallel data loading.
Yeah, there's a lot of detail in the wiki article that talks about the specific instances, because there's a lot of specifics around that, the types of relationships like lookup relationships and master detail relationships and specific circumstances where they take out locks. So it's really a great resource for you to go out to Developer Force, to the Architect Core Resources page, and check out that wiki article. There's a lot of great information there.
Hey, here's kind of an interesting question. I'm going to twist it a little bit, but the question was kind of like, why can't I just use standard tools for data loads? In other words, Sean, explain a little bit about why you built this Java program to do data loads. Why do we see customers do that all the time?
Yeah, so in large data loads, the main thing that customers do is that they'll typically either use like a middleware to assist with loading. Sometimes they'll build their own loading tools. We see this quite frequently. The data loader is, it's not, for loads that are over 5 million records, it's not not a supported nor a really what would be considered a stable enough tool to be used in terms of like a best practice. So when you're dealing with those larger data loads, the best thing to do would be to either build a program or use a middleware application.
Okay. Let's see if we can get a couple more questions here before we end up. I'm going to anticipate one. What about updates? We were doing inserts, right? So, what have you seen in your investigation, Sean, in terms of like throughput rates for updating?
Yeah, it's funny because, but whoever this particular person is, they must not have been following me.
They're not following you on Twitter.
Yeah, they're not following me on Twitter because I just answered this question for somebody out on Twitter, and really the update performance that you should see should be actually pretty similar to what we saw, in terms of insert performance.
Right.
So.
Okay. So let's see. One thing to mention again is there is code available for Sean's demos that if you want to take a look at how we use Java in this, and that was out on GitHub. Again, go to the article, and if you didn't get that bit.ly, we'll put it into the article as well. I'm not sure if it's there yet, but we'll update it this afternoon with that. Let's see. I think we've covered most ground here, Sean. I think we've really covered a lot of area, and we're about out of time. So why don't we wrap it up and say thanks to everyone again for attending today's webinar, and make sure you don't miss questions like the one that Sean just answered. Follow us on Twitter, and we're happy to help out where we can.